Okay, this is T1, or excuse me, T2, Lesson 1, Simplifying Radicals with Complex Operations. Okay, here we have two radicals. It says simplify the following. Number 1, A, square root of 36. Okay, if you punch in the square root of 36 in your calculator, you'll get 6 because 36 is 6 times 6. Square root means two numbers that are the same. But remember, when you take square root, it is plus minus because you can do a positive 6 times a positive 6, or you can do a negative 6 times a negative 6 and also get 36. So this would be your answer. However, when you punch in the square root of negative 36, chances are in your calculator, you're going to get an error. Okay? It won't do it. And it's because of this little negative. That negative makes it a non-real solution, which means the answers are not real, but they become imaginary. Some of your teachers have talked to you about this, but this negative will come outside, leaving you with an I. We're going to treat that negative as an I. Square roots of 36. Now you know what the square root of 36 is. It's plus or minus 6, but now we have to include the I because it was a complex number underneath the square root. Okay? All right, so the imaginary unit I is defined to be I equals the square root of negative 1. Using this definition, it would follow that I squared equals negative 1 because I squared equals I times I, right? And I's value right back here, I equals the square root of negative 1. So this is I. Square root of negative 1 is I. Okay? But remember, when you have a square root multiplied by itself, it takes the square root away, leaving you with just the number. Okay? So basically, I squared, I times I squared equals negative 1. You'll want to write this down, imprint that in your math filing cabinet in your brain, that I squared equals negative 1. This is what we call complex numbers. Complex numbers can be written in standard form. Here's another thing you need to write down. Can be written in standard form, A plus BI. A is when you have A plus BI, the A part is the real number. The BI is the complex number or the imaginary number. And this will be number here. Okay, all right. Okay. All right, complex numbers. Number set is compiled of all real numbers, rational and irrational, and also includes imaginary numbers. An imaginary number is a number that is multiplied by an imaginary unit called I, which is a solution to the equation x squared equals negative 1. Remember that I equals the square root of negative 1. It follows that I squared equals negative 1. I would, again, write that somewhere where you have got it. Okay? All right. The imaginary number is I equals square root of negative 1. Complex numbers are numbers that can be written in this format. The real part, A plus BI. Remember, BI is going to be the complex or imaginary. When equations with imaginary solutions are solved, the answer, and I probably should put that minus there, the answer always comes in a conjugate pair. Conjugate means plus minus. So A, let me do it over here, A plus BI and also A minus BI. Okay? All right. Okay, so here in the circle we have the real numbers. Real numbers would be like 1/2. They could be whole numbers like 5. They could be real numbers like 100. They could be real numbers like 5/4. They could be all these numbers, but then all of a sudden you get these imaginary numbers over here, and they would be like square root of negative 36, because this is going to be plus or minus 6 with an I. Okay, imaginary. They would be square root of negative 211, which would be I square roots of 211. Okay, so different things, or it could be like 5 plus 3i. Okay, so those would be your imaginary values. Okay, simplify. Okay, simplify, you can do this without a calculator. You can break down 24 to 6 times 4. You could also use 8 times 3 or 2 times 12 or 1 times 24. 6 breaks down to 3 times 2, and then I've got 2 times 2. Okay, we did this at the beginning of the year. We're looking for square root. Remember, means two things that are like. So I'll bring the 2 out here in the front, and that leaves us with the 3 times 2. But notice I did not deal with this negative. There's still a negative underneath the square root. Okay, so we're going to put 2 here, but when you bring the negative out, we are going to represent that by an I. Square roots, 3 times 2 is 6. Okay, plus or minus. Okay, so plus or minus 2i square roots of 6. Okay, simplify the square roots, kind of similar to what we've done before. Bring the negative out front. So this is going to be I square roots of 5. That is its simplified version. Okay, and I probably should have done it more exact, that when you split this up, so let me just erase what I've done here, and let's follow along what happens here. Okay, they've split this out into 2 pieces. Another way you can write this is negative 1 times 5 underneath the square root. Then you can split it out to 2 square roots. Okay, now you know what the square root of negative 1 is. It is I. And then you can put your 5 right there. Okay, let's try this one. Okay, let me kind of follow that last example there. We've got negative 1 times 16. Okay, let's split this out. So we're going to have square root of negative 1 times the square root of 16. Okay, what's another name for the square root of negative 1? I. Okay, what's another name for 16? Plus or minus 4. Okay. Let me do this. Plus or minus 4. Okay, now you're gonna you put these together, and it will be plus or minus 4 with an I. That would be your answer. Okay. Okay, square root of 12. Let's do this one again. So we've got negative 1 times 12. Let's split it off. Negative 1 times the square root of 12. Okay, square root of 12 is 2 times 2 times 3. Okay, what's another name for the square root of negative 1? I. Okay, how many pairs do I have? 2, plus or minus. What's left on the inside? 3. So what we're going to do is this would be times, would be 2 plus or minus 2i square root of 3. Okay? Okay, let's do square root of 49. Negative 1 times 49. Okay, that would be negative 1 times the square root of 49. Okay, another name for square root of negative 1? I. Square root of 49 plus or minus 7. Okay, so it will be plus or minus 7 with an I. That would be your answer. Okay? Okay. Remember, let's try some things. We're going to try multiplication. Remember, what's 2 times x? 2 times x? 2x. So just, even if you change the x to a different variable, the process is still the same. What's 3 times I? 3i. Okay? All right, now what we have here is we have 3i times 4i. Remember, when you multiply, you add the exponents. So 3 times 4 is 12 right here. And then I times I, you're going to add these two together. You're going to get right here, I times I is what? I squared. Okay, now, remember what I squared is equal to. I squared, and if you don't have this on your paper somewhere, write this down. That I squared is equal to the square root of negative 1. Okay? Right here we have this. I squared is equal to negative 1. Or I squared is equal to, excuse me, I wrote this wrong. Well, I can do what they did. Okay. To get what i's value is, or I squared's value, I squared is equal to negative 1. Okay, that's this part right here. So in place of I squared, you can substitute in negative 1, just like what they've done here. Okay, what's 12 times negative 1? Negative 12. Okay, so write this down right here. I squared is equal to negative 1. That is a big thing. All right. Okay, let's take a look at, okay, we did this example. Okay, square root of negative, let's do this one right here. So anytime that we have a square root with a negative either variable or a negative number underneath the square root, you've got to get this negative out to the front. And another name for this negative when we pull it out to the front, because remember, this is like negative 1 times the square root of r, right? Which is negative 1 times the square root of r. So what's another name for the square root of negative 1? Well, it's I. So you pull the I out front with the square root of r. Okay? Also remember this, I squared equals negative 1. If you see an I squared, substitute in negative 1 and solve. All right? Okay, so let's take a look at this. Okay, we did this earlier, square root of negative 5. Think about taking the negative out. When you take that negative out, it becomes an I. 5 will stay on the inside. Okay, this one right here, second example. 2 times 3 is what? 6. And I times I is what? I squared. What's another name for I squared? Negative 1. So 6 times negative 1 is negative 6. Okay, now this example here, 4 minus 5i. That's all you can do because 4 and 5i are not like terms. So you just leave that as your answer, 4 minus 5i. You can't combine those terms because they are not like terms. Okay, say you have add and subtract. Okay, what you're going to do is you're going to combine all of the like terms together. Okay, so 2i plus 6i minus 4i. 2 plus 6 is 8i, minus 4i is 4i, right there. And then we've got this negative 4, negative 2. Negative 4 minus 2 is negative 6, which we have right there. And this is in standard form. The real part will come first, imaginary part comes second. Okay? All right, so adding and subtracting complex numbers. Remember they have to be, we're looking for like terms. All right, here's a problem here. Remember to drop the parentheses. There's a 1 here, and you're going to distribute. 1 times 5 is 5. 1 times 5i is 5i. 1 times 4 is 4. 1 times 6i is 6i. Okay, where are our like terms? Okay, let's start with the real terms first. 5 plus 4. I'm going to put those together. And then we've got these imaginaries plus 5i plus 6i. Okay, 5 plus 4, guys, 9. 5 plus 6i, 11i. This side of my board just doesn't work the best. I apologize. So there it is, 9 plus 11i. Okay, say it again, 9 plus 11i. All right? Okay, they kind of walk you through this. I kind of went a little too fast. Let me see. Okay, all right. Okay, here we go. Add. So we've got ones in front of here. What's 1 times 3? 3. What's 1 times 2i? 2i. What's 1 times 5? 5. What's 1 times 4i? Negative 4i. Put the like terms together. I'm going to put the real things first. 3 plus 5 plus 2i minus 4i. Okay, combine. 3 plus 5 is 8. 2 minus 4 is negative 2 with an I. That is your final answer. So it's really easy. You know how to combine like terms. You know how to put things together, add, subtract, wise. It's just instead of x's and y's and z's, now we have i's. Same process. All right, here we go. This one wants you to subtract. Put ones in the front. 1 times 7 is 7. 1 times negative 5i is negative 5i. Okay. Negative 1 times negative 2 is plus 2. Negative 1 times 6i is negative 6i. Once again, put together like terms. 7 plus 2 minus 5i minus 6i. Okay. 7 plus 2 is 9. Negative 5, negative 6 is negative 11 with an I. This is in standard form. It's the real number and then the imaginary number. All right. Okay, your turn. Here we go. 6i plus 7i, 13i. Okay. Do not do I squared because you're not multiplying. Okay. Right here, this is, you have ones, distribute your ones through. So you're going to get 2 plus 3i here. You're going to get 5 plus 5i plus 6. Okay, combine like terms. We'll do 2 and 6. What's 2 and 6? 8. What's 3i and 5i? 8i. Is this in standard form? Yes, it is, because it's the real number, then the imaginary. All right, this one has ones in front, so we have 7i plus 5 plus 2i. Combine like terms. 5 is by itself, but we can put these two terms together, giving us 9i. All right, okay, here we go. This one, we're subtracting. 4 minus 8i would be negative 4i. Okay, remember when you have a negative, you've got to distribute. So we have 1 times 6i, 6i. Negative 1 times negative 2 is 2. Negative 1 times negative 7 is 7i. All right, what's 6i and 7i? Well, it's 13i. I'm going to put it back here because I want my real piece to go right there. So I have it in standard form. Okay, once again, put ones in front of here. 1 times 6i is 6i. 1 times 4 is 4. Negative 1 times negative 8 is positive 8. Negative 1 times 7i is negative 7i. Okay, we're going to combine like terms. I'm going to do the real pieces first. 4 plus 8 is 12. And then I'm going to do 6 minus 7, which gives you negative 1i. Or you can write it 12 minus I. This way or this way is great. Okay? All right. Okay, simplify again. Same thing we've been doing the whole time. 1 times 8 is 8. 1 times 7i is 7i. 1 times 4 is 4. 1 times 3i is 3i. Combine like terms. Let's start with the real pieces. 8 plus 4 is 12. And then 7i and 3i is 10i. This is in standard form. You're done. Okay. Put in ones here. Okay, 1 times 10 is 10. 1 times 2i is 2i. Negative 1 times 1 is negative 1. Negative 1 times 3i is 3i. Okay, I'm going to combine my i's. So this gives me 5i. and then 10 minus 1 is 9. Okay, is this correct? Is this in standard form? Answer is no. We want to put the real number first. Then, because this is positive, then it will be 5i. This will be your final answer. Make sure that you get it in standard form. All right, this one, a little bit more. We've got a little extra number here. 12 plus 1 times -3, -3. 1 times 4i is 4i. -1 times a, -8. -1 times -7i, 7i. Okay, what we're going to do is we're going to combine like terms. I always start with my real numbers first. 12 minus 3 is 9. 9 minus 8 is 1. Okay, then we've got 4i, 7i. That is going to give us 11i. Just remember, and you have to have this one here, guys, because you have to have a placeholder for the a value. Okay, let's do multiplying. Okay, remember, the key in multiplying complex numbers is I squared equals -1. So here's an example here that we've already gone through in a previous problem. Okay, these, do you remember how to FOIL or do the multiplication of two binomials? Okay, you'll do 1 times, or 3 times 1, which is 3. Okay, this is the FOIL process. You'll do 3 times -3i. So let me write this out. So you did 3 times 1 first, plus then you did 3 times -3i. Okay, then what you're going to do is you're going to do 2i times 1, and you can go this way if you want. 2i times 1 plus 2i times 1. Looks like I'm going to run out of room here. And then you can do 2i. Then we're going to have 2i times -3i. All right? Okay, so what happens after that? 3 times 1 is 3. There it is. 3 times -3i is -9i. 2i times 1 is 2i. And 2 times 3 is 6, -6, and I times I is I squared. Okay? All right, so far so good. Okay, then what's going to happen is this circles down a little bit, but we're going to circle these two together. So -9i plus 2i is -7i. Okay, then you've got this 3, but remember, I squared equals what? -1. Let me just kind of write this over here. 3 minus 7i minus 6 times -1. Okay, so a negative times a negative is a positive 6. Okay, now we're going to combine like terms, possibly. Okay, we'll be combining these two terms here. Okay, let's get this right here. And these right here, 3 plus 6 is what? 9, and then you've got this minus 7i. This would be your final answer. Okay, all right, we're going to multiply. Here we go. -3 times 7 is 21. -3 times 6i is -18i. That's in standard form. That's your answer. 4i times 2 is 8i. 4i times 9i is 36i squared. Okay, what do you substitute in for I squared? Anytime you see an I squared, guys, you're going to put in -1. So now I have 8i plus, positive 36 times -1 is going to be minus 36. This is not in standard form. Final answer, -36 plus 8i. Got to flip those two around to make it in standard form. All right, your turn. I times 6i is 6i squared. What's another name for I squared? -1, right there, which is -6. That's your answer. Okay, I times 4 is going to be 4i. Now, if it would help you, let me do this for teaching. I times 4 plus I times 3i. Okay, because you're going to do I times 3i. So you're going to get 4i here, and then I times I is going to be I squared. Okay, what's another name? What's another name for I squared? 4i plus 3 times negative 1. So we're going to get 4i minus 3. We've got to flip those around to negative 3 plus 4i so that it is in standard form. Okay, this one's going to be a little bit longer. 3 times 8, 3 times 9i, plus 4i times 8, and 4i times 9i. Okay, so we're going to get 24 plus 27i plus 32i plus 36i squared. Okay, I'm going to do this right now. 24 plus 27i plus 32i plus 36 times negative 1. Always I squared is negative 1. Okay, 24 plus 27i plus 32i minus 36. All right, combine like terms. 24 and negative 36, add those together, you're going to get negative 12. 27 and 32 is 59 with an I. And there's your answer. Okay? Make sure the I always goes second, real numbers in the front. All right, here we go. Negative 2 times 7 plus negative 2 times negative 5i. Okay? Plus I times 7 plus I times negative 5i. All right, here we go. These two together, negative 14. These two together, negative times negative, positive. I times 7, 7i. I times negative 5i, negative 5i squared. Okay, what's another net? Now, as soon as you write I squared, guys, so maybe you're going to start substituting. That's grand. Whatever you want to do, just make sure you do it. Okay, this is going to be negative 5 times negative 1. All right? Okay, so we've got negative 14 plus 10i plus 7i plus 5. Okay, combine like terms. These two are like terms, negative 9. 10i, 7i is going to be 17i. There you go. Easy peasy. We got this. All right. Okay, I'm only going to work a couple of examples by solving using the quadratic. We've got quadratic equations here because we've got a square. We're going to be solving using the square roots. We did this a little bit in one of our previous units, and I think it was around like MT2 lesson 5 or 4 where we had to do these. When you're solving, make sure that you're doing please excuse my dear Aunt Sally backwards, okay? So let's look at this one right here, okay? And it says give your answer in standard form with imaginary numbers. All right, okay, so you say, all right, start here. Do I have add and subtract on the side with the variable? I do. I have it in the parentheses, and I have it on the outside of the parentheses. But you want to take care of everything on the outside of the parentheses before you ever go inside. So we have a plus 4, so minus 4 to both sides. So now I've got x minus 3 squared is negative 12. All right, is there any multiply or divide on the outside of the parentheses? No. So go to the exponents. Do I have exponents? Yes. How do you undo a square? I'm going to write this here. How do you undo a square, guys? Square root. Okay, so we've got x minus 3 equals. Okay, now the square root of 12 is 2 times 2 times 3. If you have a calculator, just hit in the square root of 12 and you should get 2 square roots of 3 because I have a pair of 2's. But what about this negative? When I bring the negative outside, it's going to become an I. All right? Okay, now, remember square roots are plus or minus. So now I'm solving for x. So now, go back to the beginning here. On the left, is there any add or subtract on the side with a variable? Yes. So add 3 and add 3. Okay, so we have x equals. Now, this 3, I can't combine it with anything else because 2i is attached to this root here. Plus or minus 2i square root of 3. Okay, you guys have just written this answer in the format a plus bi. Okay, once again, start with the opposite. We have addition. Remember, please excuse my dear Aunt Sally, minus 9 to both sides. Okay, so now I'm going to get 2x plus 6 in parentheses squared is negative 9. Okay, how do I solve something being squared? I'm going to write it twice, guys. Here's why. I want you to remember this answer, but then I want you to remember what we did. We took the square root. 2x plus 6 is the square root of negative 9. All right, where do we go from here? Okay, well, let's change. What's the square root of negative 9? It's plus or minus 3, but this negative, when it comes out, is an I, right? Okay, so we are going to, maybe kind of connoit here. Plus or minus 3i. Okay, we're going to minus 6 and minus 6 here. That's a little bit better. 2x is negative 6 plus or minus 3i. Okay? All right, divide by 2, divide by 2. So x is. All right, now, in the numerator, what is the GCF in the numerator? What can I divide out of negative 6 and 3? Well, I can divide a 3 out. So let's take a 3, let's see, 3 out. Oh, that's not going to do us any good. So your final answer, negative 6 plus or minus 3i, this is an I, darn it, over 2. Now, some of you guys might be saying, hey, I can divide 2 into 6. True. You can divide 2 into 6, but you'd also have to be able to go 2 into this 3i over here. And 2 won't divide into 3 evenly without a remainder. So that is your answer. Okay? All right. Okay. Quadratics with real solutions have, this one says, using the graph to determine if solutions are real or imaginary. Okay, quadratics with real solutions have 1 or 2 intercepts. Quadratics with imaginary solutions have no x-intercepts. No x-intercepts means it's not going to cross the x-axis. I'll just do a couple of these, and here we go. All right, this one is actually in vertex form. I'm going to rewrite this out here as y equals negative 1/3 times x minus 0 squared minus 3. So the vertex is at 0, negative 3. 0, negative 3 right here. Okay, negative 1/3. This is your A value. This is A, guys. And if A is negative, it's going to turn down. So from here, I know it's going to turn down. So is it ever going to cross the x-axis? No. So these are imaginary. And how would I know what the imaginary solutions are? Well, you can work the quadratic equation, right? Okay, or make a table, either way. Okay, but having vertex form is pretty easy. Okay, this is your A right here. Okay, your A is negative 1. Okay, the vertex is at 10, 5. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. So it's going to be somewhere here. Okay, now this one, our a is -1. So this means our quadratic is actually going to turn down. So it is going to cross the x-axis in a couple of places. So we're going to have two x-intercepts. So we can just say 2 x-intercepts. You can abbreviate it. That's really all they want, is they just want you to be able to tell what's happening on the graph. All right, okay, so let's see here. All right. Okay, so our A here in C is -5. B is going to be 0. In fact, let me just start right here. Well, our A is -5. Let's just write that down. Okay, this is going to be -5 times x minus 0, because there's nothing here in the H position, squared plus 25. Okay, so our vertex is at 0, 25. Okay, so I'm going to go 5, 10, 15. Let's do, I don't know, let's do 10s. 10, 20, 25. 0, 25. There it is. Okay, so our A value is negative. This is our A value. A is -5, right? So that means our graph is going to turn down, which means it's going to do something like this. So that creates two x-intercepts. Okay, let me rewrite this. That wasn't very good. X-intercepts. All right. Okay. Let's do. Okay, now D is in x-intercept form. This is x equals -3. This is going to be x is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3. Okay, we've got x-intercepts because this is in x-intercept form. +1, this is your A. +1/2 means it's going to turn up. Now halfway between 3 and 12, 15, the distance is 15 to 3, 4, 5, 6, 7, I don't know, maybe 8. Okay, this might be where your vertex is. It's going to come down and then it's going to go up. I could actually find the vertex, but I'm just sketching the general shape just to see if it's got two x-intercepts or no x-intercepts. Okay? All right. Okay, this vertex here is at -4, 20. Okay, -4, 1, 2, 3, 4, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20. This is going to be 20 up here, so 420. Our 5, our A is positive, so it means it's going to turn up. So this one is going to have no x-intercepts. So it would be 2 imaginary solutions. Okay, remember out here is a 0 on F, so our vertex is at 3, 0. So let's do it. 1, 2, 3, 0 right here. Our A is positive, so it's going to turn up. It's going to go like this. So how many times does it hit the x-axis? 1 x-intercept. Okay? All right. Okay, we learned about vertex in about lesson MT2, lesson 4. So if you need to go back and review that, do it. All right. Okay. Now, okay, this is kind of on repeat. So here's the deal. Finish up, do your delta math. Okay, lesson 1, finish it. Finish up your complex worksheet. If your teacher has given you one, do your delta math assignment. And best of luck. Thank you.